Today we're going to be talking about security threats and evolving your thinking about how to address these new security threats. So when we think about threats that are addressing your business or your users, you have several new problems. The bad guys out there have become increasingly more sophisticated. Their attacks are often well organized and very complex in nature and difficult to defend against. Now at the same time, your user base is not making your job any easier. Your users want to do things on mobile devices. They want to do things across platform. They want things to be easy. They want security to be seamless, which is often a counterintuitive proposition. Now, when we start talking about the types of security threats that are being addressed today, we want to talk first about the ones that are kind of the standard same old, same old. This is I have an on-premise system. It needs to be patched on a regular basis. You're ultimately not successful. But here's an example from the press. This is one where both the Ukrainian government and NATO were attacked by hackers going through a known vulnerability in an existing on-premise platform. This is the kind of security threat that we've addressed for years, but this is not really interesting. The new threats are much more sophisticated. You can't really talk about hacking without having to talk about Sony. The Sony attack, for those of you who don't know, was a malware-based attack that came in, we're not actually sure, via an email or via a web session, and it spread through all their on-premise systems. They went in, they took all their email, all their documents, pulled them out of the system, and then they went ahead and wiped all the servers clean. This is the new sort of threat that you need to be able to defend yourself against. If we'd like to go a step further, we can talk about JPMorgan Chase. This is the largest data breach in US history. Again, an unpatched server on the edge, but what makes this different is the types of attackers. This was an organized group operating internationally from countries from the US to Israel to Eastern Europe. And what happened is once they breached their systems, they found the sensitive data and then they held it. They didn't expose it or use it until the price of that data hit the appropriate level on the black market. You're working against not just a couple of geeks in their basement trying to make a name for yourselves. You're working against a sophisticated set of users in a very for-profit business. Last but not least, let's talk about state-sponsored hacks. So in the US, the FBI has gone on record and said there are basically two kinds of organizations out there. You have companies that have been hacked by the Chinese, and then you have companies that don't realize that they've been hacked by the Chinese. Now, we can't just pick on one group or one government because there are many governments, both friendly and less friendly, who are attacking infrastructure for data mining purposes. Now, what I want to do now is talk a little bit about Google. So most people don't understand the scale in which we operate, so I'm going to share a few Google secrets with you. So firstly, this is a picture of one of our data centers. It's not a particularly exciting picture, but what you see in this picture is special. Everything here is custom made for and by Google. And what does that mean? That means on any given day of the year, we're the world's third or fourth largest manufacturer of servers in the world. This is sourcing our own silicon. Everything from custom motherboards, proprietary operating systems, networking equipment, HVAC, etc. is all custom made for and by Google. Let me give you a further example. So on the right here is a picture of one of what we call our Jupyter Superblock. This is a switch that we designed that pushes 40 terabits a second of data across our network. That's the equivalent of 40 million high-speed home internet connections. Now, on the left here is another one of our innovations. This is our Pluto switch. This sits on top of a storage array. Now, we did all of this customization not just to be cool, right? We had to meet requirements that effectively didn't exist in the market before. We couldn't go and buy things off the shelf to solve our problems. And from a security perspective, this gives us some really amazing advantages. We have security by obscurity. Because you can't go out and buy our server or our OSs or anything and reverse engineer them, people don't understand how we operate. It makes it difficult for us to be attacked. Now, when we start talking about because we own the whole stack, we actually are not inheriting security problems, whether built in on purpose or on accident, from third-party vendors. We're in charge of everything, and if there is a vulnerability, we're in charge of fixing it so we can respond very quickly. This customization at the networking level, when we talk about building this equipment, it's not just about providing a service. We've actually had to build our own internal networking protocols. So our equipment speaks a language internally to Google that doesn't get spoken outside. And we have different protocols in different parts of the country and different data centers to further segregate and secure our information. We haven't even gotten to the cool stuff yet. The cool stuff is our network.
It doesn't matter how you measure our network, by length, by traffic, by ingress, degress of data, we have the largest network in the world. This is dark and light fiber across every continent on the planet other than Antarctica, 13 undersea cables across the Atlantic and the Pacific. Our network just doesn't connect our data centers to each other. It connects our data centers to nearly every ISP in the world. There's a couple dark heart of Africa places where we're still 2 hops away. But this is our differentiator. Now, what does this mean from a security perspective? Well, we can talk about where's your data at risk. It's typically at risk when it's in transit. With Google, your users are typically 1 hop away. It doesn't matter what device they're on, they go from their device, their ISP, and you're on Google's network now. And this also has great other benefits. So we can collaborate in real time. We have low latency. You can operate across the world without having to worry about where data centers are located, or these sorts of things. It just works. And this is how we deliver all of our solutions: search, YouTube, etc. Our network is so big, on any given day, we're holding between 25 to 38% of total internet traffic. Because we operate globally, we can correlate security events that other regional players or even larger players simply can't. So what might seem like a little anomaly here, it actually could be part of something much bigger. So you think about things like DDoS attacks, so distributed denial of service attacks. We can not only detect those in real time, we can stop them. So we've even extended this as a project to protect journalists and free speech advocates from being blasted by third parties. This is something we can just do in real time without our engineering team needing to be paged. When was the last time you saw Google.com down? It's not because they're not trying. Now, let's talk about something really interesting. So we've actually solved one of the more difficult computer science problems at Google, and we've done a terrible job of explaining it to the world. So I'm going to try and do that today. So to back up, something that people don't talk about, but they should, is talking about reliability of a service. And if you're in IT, we typically measure this with an SLA, right? And SLAs, this is the service level agreement, like I'm going to guarantee the service is available for X amount of time. Now, I think with modern solutions, this has gotten a bit foggy. Somehow everyone gets to 5 nines of availability, but it's still down for maintenance on Sunday. How is that possible, right? With us, we prefer to use a more precise engineering metric. It's called MTBF, mean time between failures. And if you go out and buy like one enterprise-grade device, you can expect that to last for 10 years before it catches on fire and catastrophically fails, on average. The problem is scale. Go from 1 device to 100,000 devices, your failure rate drops from it's 1 failure every 10 years to a failure every hour. Now, scale that up to Google size, with literally millions and millions and millions of devices. We have a constant rate of failure, always hardware, network, software. Something's always broken. And this is the problem when we start looking at large enterprise solutions. It's great when it's small, but as soon as it becomes big, it's hard to manage, it's hard to secure, it's hard to keep it up and running, right? We talk about where are you investing your spend, right? I'm spending 70% of my money keeping the lights on. Well, that's not a good thing. So with Google, at our scale, with a constant rate of failure, how are we able to provide one of the most resilient internet services out there? And it comes down to how we actually store and process data. Now, at Google, it's hard to say this without coming off as arrogant, because it's not meant that way. We're really, really ahead. When we say we're not on the cutting edge, we're on the bleeding edge. We're 10 years ahead. The technologies that we used 10 years ago are the ones that are being out there sold in the market. You hear about big data. We invented the NoSQL database, right? We invented these technologies, and we've been iterating since then. So let me explain how we store and process data, which is completely different from how everyone else does it, but it's easy to get your head around. So think of it like this. Every single application that Google has, let's say it's Gmail or Google Drive or what have you, you have an instance per user. Those are databases associated with you. Your email, your attachments, the index so you can search that content, right? What happens when you actually store that at Google is the following. I want to upload a file to Google Drive. I upload the file, it goes to the storage layer. It gets put to my personal database. I'm going to take that database, I'm going to break it into literally thousands of pieces. I'm going to break it into thousands of pieces, and then I'm going to run what's called algorithmic encryption. So this is running it through an algorithm. It makes it non-humanly readable. If I were to write it to a disk at this moment, I wouldn't be able to tell who it belongs to or what application it goes to. After I've done algorithmic encryption, I'm now going to do key-based encryption. So then I'm going to encrypt it with AES, as you'd imagine, normal standard encryption. Then I'm going to take the key that I used to encrypt it. I'm going to wrap that and encrypt it a second time and keep it in an enterprise key management store. Now, after I've taken the data, sharded it, obfuscated it, doubly encrypted it, now I'm going to replicate it. So each tiny piece I'm going to take, I'm going to replicate it 5 times data center number 1. Different drives, different servers, different racks, different connectivity to the internet. Then bang, 5 more times data center number 2, 5 more times data center number 3, 5 more times data center number 4. When it comes time to access this information, what am I going to do? I'm going to go out, the algorithm is going to say, I want that file again. So it goes out, the algorithm gets every single copy of every single shard. It's going to erase it all back together. It's going to reassemble it, de-encrypt it, de-obfuscate it, and then present it to the user in real time. It's like a computer science miracle, right? It's very, very cool. And the reason that we do this is because this is the only way that we can get to this. There's always going to be a problem. And the idea is that the infrastructure is self-healing. It's self-adjusting. If there's an earthquake or a power outage or something, your screen doesn't flicker. You continue to be able to consume these services. And because of the way that we store the information, it's not we're encrypting it at a file level. We're taking it a database, fragmenting it, obfuscating it, and then doubly encrypting it at multiple levels. So if there was to be some sort of breach or internal actor or someone trying to do something, they have a piece of a very large puzzle. It makes it very, very difficult. If you really want to know about how we do encryption at Google, we've actually written and shared a very detailed encryption white paper. This is just one of the flows where we can talk about how we protect the data at rest. This is something we can share with you guys, or you can send it to your security officer, and I'm happy to take questions on it. But we're very, very open about that. Another thing that comes up is people are often concerned, where's the data located? Now, with us, first of all, we tell you. There's a list of data centers. We have them all here. We share them with everyone. But the thing to consider here is that your data is not in 1 or 2 of these locations. Your data is everywhere and nowhere at the same time. It's fragmented, obfuscated, encrypted, and then replicated across our global data center network. And because of that reach of that network, latency is no longer a problem. It doesn't matter. I could keep it in Oklahoma, or I could keep it in Finland. The performance is still going to be the same for you. Now, because of the way, again, in which this is stored, it makes it very difficult to attack you. We use these data centers not just for providing services to enterprise customers. We use it for everything. So if someone wanted to attack your company, they need to literally attack all of Google. They need to be able to sort out and try and discover traffic. Every YouTube video, cat video we're showing, internet search, you name it, it's all going through the same front ends. So it's very, very hard to be able to attack you. Now, we encrypt all of our services here at Rest. So we've made some huge strides here in engineering. So we used to only do algorithmic-based encryption. Now we've upped our game. Now we're also doing algorithmic-based encryption. In addition, we're doing multiple levels of key-based encryption for all of the services we have here. There are a couple of asterisks here, and just let me explain that very quickly. Google, some of these Google file formats, you can actually embed content from other data sources. So let's say that you have a WordPress file that you want to put on your website. If you're embedding third-party information, we're not encrypting the third-party information, but everything on our platform is encrypted. It's literally that simple. So in a mobile-first world, what have we learned? The traditional thinking of having walls around everything, focusing all your security, just, oh, it's going to be on my secure network, that doesn't work anymore, right? The reason that we did that is because we didn't have these infinite budgets, and we said, okay, we need to focus on security. What was the logical place to focus on was the network. But at Google, we've actually published a white paper. It's called Beyond Corp. And our philosophy is that there's no such thing as a secure network anymore, whether it's run by a government or a company. At Google, we assume everything is breached. We assume everything is broken, and that's the only way to protect yourself. When we start talking about secure architecture, you can't just be good at one thing. You have to own the entire stack. And for most companies and organizations, this is incredibly expensive. There's no way you're going to get budget to do this. So Google, the scale that we operate on, we literally invest billions of dollars in this. Because we're investing at this scale, we're able to do things that other companies simply can't. We start talking about security and how that's built in depth. Most people don't realize that, yes, we look at our data centers, we look at our network, we secure all the information, but where do most of the breaches occur? They haven't hacked into a data center. They've done social networking, or they've installed something on your browser or on your device. So what can we do to protect you there? A few things. Firstly, we have Chrome as a browser. So we have a version of Chrome. It's called Chrome for Work. You can use it. It's free. But Chrome for Work, what makes it different is you can apply up to 280 security policies to Chrome. And you can say, well, I could do that with Internet Explorer. But Internet Explorer, it just ran on Windows. Chrome, it runs on Windows, it runs on Macs, it runs on Linux, it runs on iPhones, it runs on Android, it runs on all the Chrome devices. You can now have one set of security policies and apply it across all your different devices and have them all act as first-class citizens. This is a good thing to do. Where are those breaches happening? It's that old enemy of ours, that password, right? The username and the password. And what happens? It's that thing that you tell your users not to do. You say, please don't use your password on other sites. What do they do? Everyone has the favorite password. They reuse it over and over and over again. So at Google, what we're trying to do is we're trying to make the password irrelevant. So we have multi-factor authentication. We've actually given you guys goodie bags. And in the goodie bags here, we've given you some of our security keys. You can use that with your personal Gmail accounts. You can also use them with corporate accounts. These things they're not made by Google. They're based on an open standard. You can make them yourself. If you're a retailer, you could make them and sell them. You're more than welcome to do so. But the idea with multi-factor authentication is that username and password is irrelevant without a code or having a phone nearby, which is connecting via Bluetooth or et cetera. This is the next step to get around that social engineering. There's another cool thing I don't have a slide for, but I just want to share with you. We have internally at Google, which we've now released out into the wild. Remember, I talked about those security policies in Chrome? We've released a Chrome extension, which is called Password Watch. And what this does, it's a Chrome extension you can require via policy, and it takes a portion of your corporate password, a portion of it, not the whole thing. It's hashed, it's salted, it's stored on the browser, it's not at Google. And what happens is it's watching what your users are doing. And if someone tries to reuse your corporate password on another website, locks the account. Every Googler has done this. I've done this. So it's the end of the night, I'm sleepy, I go to another website, I accidentally, that password's muscle memory, right? I accidentally put in my wrong password, I'm like, oh no. Now I need to reset, everything is off now. Now I need to go back and reset all my accounts. It's that kind of proactive security that we want to talk about using to protect yourself. Of course, we have an amazing story on encryption. We have encryption at rest in our data centers. When we talk about protecting encryption in transit at Google, we use a technology called perfect forward secrecy. This is stronger than most even military-grade VPNs. Effectively, what this is that for every single user, for every single web session, they have a unique set of certificates, hardened to 2048-bit strength. If you're using mobile devices, it's a mobile-first world out there. On our platform, we have Android for Work. This uses SE Linux to create a secure container on the device where you can store your corporate information and manage the device. Not everybody's on Android. We can do the same thing with iOS, with the native iOS MDM, MAM APIs. Again, enforcing things like encryption, data management. That's all part of our platform. But if you have another third-party solution, we play nice with everyone else. It's use the bits that make sense for your organization. If you guys have a robust authentication system for your company, we work with governments and militaries as well. If you want to be able to have a username, a password, a token, a retinal scan, a blood sample, if that's what you want to do, if you want to manage that, that's something we can integrate with all those different systems. We have lots of customers with great examples. So I'm going to talk a little bit about product, but only in light of security. So we have a product called Google Drive. And what Google Drive is, think of it as a huge unlimited hard drive in the sky for your data. The only limit is that each file size, the maximum size a file can be, is 5 terabytes. So if you have one that's bigger than that, I'm sorry, not yet. It'll probably be coming. But you can have as many of them as you want. The amazing thing about Google Drive is that it works with all the different file formats, not just Google stuff, Microsoft, OpenOffice, Adobe, whatever. Whatever you have, or just big files of data, you can upload them here. And it becomes very, very easy to share, and it's available on different devices. But the great thing about Drive is that it's easy to share, and the scary thing about Drive is that it's easy to share. I want to be able to control what's happening to my information. So if you've never seen a sharing dialog within Google Drive, the way that it works is that every single document has strict permissions. Now, with the strict permissions, I can invite individual users within my company to have access to that. And I can have them view it, I can have them edit it, I can have them collaborate it, and all these things are there, and I can actually, this box is off here, put information rights management on it. Now, this is a problem we've been trying to solve in IT for a long time. So I want IRM. So I want to be able to prevent people from copying, downloading, or printing this information. When you combine IRM with permissions like this, you have real control of your data. When I want to share a document with you, I send an email, it has a link, I click on the link, and if I decide later that you shouldn't have access anymore, I remove your access. That data has never left the cloud, and it's not available on their device anymore. But let's say you really want to control who you share with. So lots of folks say, well, I want to share my information, I want to collaborate, but I want to control the collaboration. So now we've said you can whitelist organizations outside of your own who you'd like to collaborate with. So it's not just the entire world. You can limit it to a set of other organizations. So this is having real control of your data. And again, this works within any file format. Other cool stuff. Security matters, and scale matters in security more than anything else. If you're going to scale in any area, you have to scale in security. And at Google, we have over 500 full-time engineers working on security all of the time. That's more than most IT departments. And our guys, they're very, very good, but there are lots of smart people outside of Google. So we collaborate with the academic research community, the security community. We've published a whole bunch of white papers on security, over 160. If you don't believe any of the claims I'm making today, we are the first company to have what we call a bug bounty program. So if you don't believe that our security is so good, you're welcome to try and hack it yourself. Conduct your own penetration test. You don't have to call me. If you can find something interesting, I got some money for you. I can make you famous. I can give you a t-shirt. If you do something really impressive, maybe a job. But this is out there. This is the proof that's in the pudding. I've had, I think, 6 customers in the last 6 months conduct penetration tests against us. Nothing. I went and talked to a government customer in Australia. They were in the military. And they were talking about the security of their network, and I threw it down. I was like, well, let's run a pen test on your network and mine. I know who's going to come up on top. And this can be part of an evaluation. And it's not being cocky, but it's saying there's a difference between perceived security and actual security, and we're interested in actual security. Of course, it wouldn't be any fun just to say, come try and hack us if we didn't try and hack other people. So we've gone out, we have a team at Google, they're called Project Zero, and this is where we're hacking our friends in Redmond and our friends in Cupertino, but we're nice, right? We're not bad guys. So when we find vulnerabilities, we tell them about it, but the only catch is that we only give them 30 days to fix it. Now for Google, 30 days is a very long time. For some of our competitors, 30 days is not near enough. And if they don't fix it, we shame them publicly, and we release it. So it entices them to do the right thing. And the reason that we do this, we're not being mean, it's just that our philosophy is that if the cloud is not secure for everyone, then it's secure for no one. So we're all better off working together. Now, the way in which we run our infrastructure, it makes us very agile with security. And when I'm talking about agility, you could think about a zero-day attack, how that works today. So there's a new zero-day attack. What do you have to do today? Well, it has to come out, it has to be discovered. After it's discovered, you're going to go and work with your AV vendor. You're going to say, please give me a fix. They're going to develop a fix. They're going to give it to you. Then you're going to have to distribute it. You're going to have to install it. You're going to have to go through all this, right? It's been like, how many days have passed already? Right, you've already been on. The Chinese are in and out. With Google, the way that this works, if there's a zero-day attack, first of all, we're the world's largest email provider. We have over 900 million active accounts. And when we talk about AV and vulnerability scanning, we have multiple layers. In addition to that, there's a company out there called VirusTotal. That's a Google company. Their sole reason for existing is to facilitate the identification and addressing of malware and threats. Now, in that same zero-day attack scenario, there's a new zero-day attack. It attacks a Gmail user in Mumbai. Not only can we protect that one user in Mumbai, we can then immediately protect all other 900 million accounts in real time. This is the speed you have to move at to stay ahead of those bad actors I was talking about in the beginning of the presentation. And we can actually prevent incidents now before they even happened. You guys heard about the Heartbleed SSL vulnerability? That was a big one last year. The Poodle SSL exploit. We discovered all of those. So before they were even announced, we were patched and fixed. We're not always going to be the first one to find a bug, but because of the way that we run our infrastructure, it's fixed once, fixed everywhere. And we think this is the only way where you really have a chance to stay ahead of those bad actors. We get past security actually pretty quickly. When I talk to customers, when I explain to them how we do things, we have lots of independent verification, you're right, you can test this. They buy the security very quickly. The problem now is people worry more about what's happening to their data right? It quickly goes from security, no, I believe your security is better than ours. Let's talk about what's happening to the data. And there's a lot of misinformation about it. So how does Google think about data protection? We think about it two ways. So I always like to start the talk with security, because without security, if you don't have good security, you're not going to have data protection. The other component is privacy. If you don't have a solid privacy policy and policy practices in place, you're not going to have it either. So what do we think at Google? The number one piece of misinformation that I get is people confuse our consumer services, the ones that we offer for free, with the services that we offer to companies, businesses, schools, and nonprofits. They're completely different. Just to be clear, for that free Gmail account that you sign up for, yes, we're using the data for advertising. Yes, there's profiling, yes, there's scanning. But for all of the products that we offer to businesses, schools, nonprofits, that is not the case. In that case, in the original case, you guys own the data. We're simply considered the data processor. We can only use the data in the way in which you've instructed us. Let me go into a bit more detail here. This means that we see this as having three big components, like three legs in a stool, really. So the first component is transparency. So what transparency means is that we're going to tell you what we're doing with your data. And it's about being transparent before you're a customer without having to sign, some sort of magical special agreement. So this is sharing things like where our data centers are located, our security reports, our SOC 3 reports, our ISO reports. All of our contracts are public, our data processing, who our sub-processors are. All these components are commitments around data deletion, what data can be used for. This is all publicly available, right? You can look it up now, it's on the web. And what it comes down to is what can we use the data for? We can use the data for absolutely nothing but what you instruct us to do. So just to be clear, we cannot use that for advertising. We cannot mine your data for any purpose whatsoever, even to improve our own product. We're not allowed to do so, and this is part of our contract. We'll talk about that in a minute. The intellectual property of the data is yours. We literally have zero rights on it. We own the rights to our service, so as long as you don't try to reverse engineer Gmail, we're going to be okay. Portability. You could literally take your entire organization's data and shift it into Google over the weekend. We say that we can move as fast as you can make decisions, but let's say that you like to make a lot of decisions, and you change your mind next week and you want to move everything out of Google. You can do that. There's no penalty. It comes out in usable formats. It works so well, our competitors have built tools around it to quickly expedite the movement of data in and out of our platform. Now, the first thing, we tell you what we're going to do. The next thing, we legally commit to what we're going to do. So the second point is having strong contracts. All of our contracts they're written in a very kind of European-centric language. It's not because we're a European company. It's just that the standards there are very, very specific when it comes to data. So there, you're the data controller, you're the data owner, you give us instructions, we're the data processor, we can only do what you tell us. We have a global data privacy policy that applies to businesses, schools, and nonprofits. It's different from the one that if you go Google privacy policy, it's not that one. That's for consumers. This one is publicly available, and we update this all the time. We updated it just this week because we're constantly getting feedback from data protection authorities in the US, in Europe, in Asia, and our position is that we will only strengthen our commitments, not weaken them. So one of the more recent ones is we put an SLA on data deletion. We made ongoing commitments to maintain compliance with our security audits and our data privacy audits, which I'll talk to you about here in a moment. These sorts of things, this is all available, which is very useful for business. So if you're a parent in a school and you want to know what's happening to your children's data, you can just go out and read it. There's no advertising, there's no scanning. It's not some secret contract that's each company has their own thing agreed upon, right? We build on it. We tell you what we're going to do, we're transparent, we legally commit, but how do you really know what we're doing, right? Can you trust us? Well, we believe at Google that you should trust but verify. So the verification is the auditing component. And the problems in the past is that all of our audits have been very, very focused on security. You start with security. Security is strong. So we have all the ones that you'd expect. ISO 27001, SOC 2, SOC 3, SSA 16, ISA 3402. Again, these are all independent security audits. But again, we get past that security conversation pretty quickly. It goes into data usage. People don't argue about security. They know what good security is. They argue about data usage and how data should be protected. Should it be transferred internationally? How does all that work? So what did Google do? We thought this is a big problem. We need a way to solve it. So we went and worked with our buddies over at ISO, our Swiss friends, our standard settings organization, and we worked with them to develop a new standard. So the new standard is called ISO 27018. And what this does, it's about data privacy, the processing of personally identifiable information by public clouds, which is us, right? It's exactly what we're looking for. The next thing we did is we had to work with our auditor to be able to audit us against this new standard. So remember our infrastructure, everything I talked about being completely customized? We can't run an audit sending a college kid in with a clipboard saying, there's my Blade server and what's my patch level. It doesn't work that way. At Google, everything's customized. We have to embed our auditors with our engineering teams. It takes a long time. It took us over a year for them to be trained on our platform, and then be able to conduct an audit afterwards. But the good news here is that we've adopted the standard, and we've had this since September. So it took us we announced it on almost a year to the date after the standard had been released. Just so you understand how important this is, let me talk a little bit about how these standards work if you're not familiar with them. ISO 27001, it's a family of standards. So the first level here is this definition. The first level here is around security. There's 114 security controls, which goes back to our story. You have to have security before you can have privacy. After you've gone through and we talk about all these different controls that are in place for our platform, ISO 27018 is built on top of it. You have to have security before you can have data protection. And these are looking at different things. This is saying, is Gmail secure? Is it locked down? All those controls in place. Next one, what's that data being used for? Is it guaranteed that it's not being used by other systems? What's out there? How is this being protected? And this is what's important. So now for the first time, you have independent, third-party, audited verification on what's happening to your data. So this is something that you can take to your board. This is something that you can tell your users about. But what makes it interesting when we start talking about things like data privacy is that it just doesn't apply to services like security. So for security, I'd say, yeah, Gmail, Drive, all of our products are covered, but data is different, right? You can get to that from all kinds of different ways. So for our privacy standard, yes, it had to cover the applications, but it had to cover every way that you could get to the data. So all the APIs, all the SDKs, or the software development kits, and tools that you might want to run on top of them. So all these have been included as well. Another benefit of working with a company like Google who operates around the world is that we operate around the world, and that means that different countries, different regions have different standards relating to data privacy. And for us, we always have to take the strictest one, right? Sometimes it's Europe, sometimes it's Korea, sometimes it's the US. And these sorts of things, knowing that we have to meet all of these strict standards, you can have peace of mind that this is something that's important to us and that we're going to be on the leading edge of what's happening with data protection around security and data privacy. We also have a very, very large team, both in DC, in Brussels, in Singapore, working with governments, working with data protection authorities, because this is an evolving thing. In Europe, there's a lot of change happening right now. We're compliant with everything that's happening there now. We work very, very closely with them. But this is something that is constantly developing. And because we have such a vested interest in all these markets, it's in our interest to be compliant and to be a leader. And this is something that we're really trying to bring home. So when you talk about moving to the cloud, now you can think about the abilities, but does this increase the risk for what you're doing on a day-to-day basis at your business? We think that you should look at it as a risk assessment. We talk about having extraordinarily strong, world-class, leading-edge security. That's great, but it's only part of the problem. You have to understand how that data is being used, what systems are there, having all this information available. We're very, very happy to share with you guys extraordinarily detailed security audit reports to back all these claims up. You can run your own penetration testing, all these sorts of things. Having strict, bulletproof contracts about what your data can and cannot be used for. Having very, very strong enforcement mechanisms for them there. So this is what we talk about. We want to say that we want you to not just look at our platform as being the same as to what you have or being equivalent. We want to be 10 times better. We want to help catapult you guys up to the next level.